Now for division with complex numbers. All of our problems in the book say do this and then express it in standard form. In order to do this, we're going to do the same sort of thing that we would do if we had 4 plus the square root of x, for instance, in the denominator. We're going to multiply by a carefully chosen form of the number 1 that involves the conjugate of this gizmo in the denominator. There it is. Now, complex number over complex number, it's still same over same, and it's still equal to 1. In the numerator, we have scalar multiplication. In the denominator, we have FOIL multiplication. No, we don't. This is one of our special cases, and we need to treat it as a special case without thinking about it. Foiling would be a real waste of time here. So, here we are. We didn't FOIL the bottom. We used the special case. We got 4 squared plus 1 squared, and then we still have a multiplication, a scalar multiplication in the denominator to carry out. So we do. And right now we are almost in standard form. Not quite. My slides are a little out of order here. Oops, there it is. Okay, so there's our standard form. We need to break up that numerator. We're going to divide each piece by the denominator separately to get a standard form complex number as a result. Okay, here's another one, and now the only difference here is that we have an imaginary scalar in the numerator. We take this carefully chosen form of the number 1 that has the conjugate of the denominator on the left in both the numerator and denominator. A mistake that I often see here is people will put 2 minus I here on the right, and then they'll put 2 plus I or 2 minus I in the numerator. Either way, that isn't going to work out. You've got to have the conjugate here for this to work out. Now I hope as you are watching this, you are trying it on your own before you go on to the next bit. You can hit a space bar in YouTube and that will stop the video, and then you hit the space bar to make it go again. Okay, so here's the rest of this second division with a scalar multiplication in the top, and finally a great simplification. Standard form includes the simplification of these. I'm not a maniac for simplification as a rule, but in this case, in that standard form is required for all of these complex numbers, we will absolutely simplify.